All right, number one, at what point on the graph of y equals 1/2 x squared minus 3/2 is the tangent line parallel to the line 4x minus 8y equals 5? So we want to figure out if you know the two lines are parallel, that means their slopes are the same. So right now, I gave you this graph. We have y equals 1/2 x squared minus 3/2. If I want to get the slope, I want to take the derivative. So dy over dx is x, and that's it. So the 2 comes down and it cancels with the 1/2. So that's the slope at any point on that graph. Now, we also have 4x minus 8y equals 5. We solve this for y, put it into y equals mx plus b form, we'll be able to get the slope of this line. So subtract 4x. We get negative 8y is negative 4x plus 5. Divide by negative 8. We get y is 1/2 x plus negative 5/8. Now here you could take the derivative if you wanted to, but the slope is a half. And we want this to equal, x to equal 1/2. So now we know x is 1/2 because the slope is just x, because that was the derivative. So x is 1/2. So now we're down to two choices. See, that's what's the beauty about this question. You're down to two choices. Now we have to get the y value. It's the point on the graph. It's the point on the graph of y equals 1/2 x squared minus 3/2. So we need to use that curve, that equation, to get the y coordinate. So y is 1/2 times 1/2 squared minus 3/2. So y is half squared is a quarter times a half is an eighth minus 3/2. Getting equivalent denominators, the common denominator is 8. So multiply by 4 over 4, and you would get 12/8, which is negative 11 over 8. So that's the y coordinate. So it makes the final answer choice B. Great problem. I like that one. Number 2. The curve of y equals 2x squared over 4 minus x squared. Horizontal and vertical asymptotes. First of all, you always look and see if you can simplify the function. And in this case, you can't. We look to see if we can simplify this function, and we can't. All right, so now we want to figure out what types of asymptotes it has. Vertical asymptotes are easy. If you simplified, you set the denominator equal to 0. So negative x squared is negative 4. So x squared is 4. So x is plus or minus 2. So the function is two vertical asymptotes. So guess what? Choice A is gone because it doesn't mention vertical asymptotes. Choice B is gone because it mentioned only one vertical asymptote. Choice D is gone and only mentions one vertical asymptote. So now, just by doing that simple little thing, we're down to two choices. All right, now we also have to take into account, if we want to talk about the horizontal asymptotes, that's equivalent to thinking about the limit as x goes to positive and negative infinity. So if we take the limit as x goes to positive or negative infinity of this function, the long way, or the mathematically correct way to do this, or mathematically rigorous way to do this, is divide by the highest power in the denominator, which is x squared. And you're going to get the same answer if x is going to positive or negative infinity for this, because you're going to get 2 over 4 minus x squared minus 1, where this baby fraction is going to 0. So 2 over negative 1 is negative 2, regardless of whether x is going to positive or negative infinity. So there is one horizontal asymptote at y equals negative 2, and so the answer is choice E. Alternatively, more quickly, the degrees of the top and the bottom are tied. So we know there is going to be only one horizontal asymptote at the ratio of the coefficients, which is 2 over negative 1. All right, number 3, we have this function, and it says which statement is true? F of x is discontinuous only at x is equal to negative 2. Well, let's find out. At negative 2, okay, if you take a look here, if I try to find f of negative 2, we can't plug into the top rule directly because x has to be less than 2. And we can't plug into the middle rule because x is greater than negative 2. So f of negative 2 actually doesn't even have a value. It's undefined. So clearly, if f of negative 2 is undefined, this means the function is definitely discontinuous at x equals negative 2. So now we don't necessarily know it's only discontinuous there. All right, so now we have now they're talking about x equals 1 in the choices, so we have to also look at x equals 1. So if you think about a graph of f of x at the moment, right? F of x is 4 between x equals negative 2 with a hole there and 1. Okay, and then f of x is 6 minus x when x is greater than 1. But if we plugged in 1 into here, 6 minus 1 is 5. So when x is greater than 1, or sorry, when x is 1, 6 minus x is 5. So what happens is that this is at 4. So what happens is we get an open hole at 5, and this graph has a negative slope, so the graph's going down. So there is a point of discontinuity at 1 as well, essentially because the two functions don't match up. This is 4 at x equals 1, and this guy is 5 at x equals 1. So there is a mismatch there. So the function is discontinuous at x equals negative 2 and at 1, so choice E. Obviously, A and B are out because there's 2 points of discontinuity. F of negative 2 is let's look at choice C for a minute. If f of negative 2 is defined to be 4, then f will be continuous everywhere. Well, that's not true because that doesn't take care of the discontinuity at 1. And f is not continuous everywhere. So choice E is the answer. All right, number 4, if f of x is that function, the limit as x approaches 3 of f of x. Yes, you have to think of the shutter method here in some sense. We have to get the limit from the left and the limit from the right and see if they agree, because x equals 3 is kind of the glue point of the function. So from the left, we're going to use the top rule. So this would be limit as x approaches 3 from the left of ln of 3x, which you always try to plug in the limiting value. So it's ln of 3 times 3, which is natural log of 9. Okay, great. So that's the limit from the left. Limit from the right, we have to use the rule x ln of 3. So we have the limit as x approaches 3 from the right of x ln of 3, which is 3 ln of 3. Just as a side note, you don't have a calculator, so you have to figure out if these two answers are the same or not. There's a property of logs that says I can bring a coefficient as an exponent. So this is really equal to ln of 3 to the third, which is ln of not 9, but 27. So clearly, these are not equal to each other, so the limit is non-existent. Number 5, if f of x is cosine of e to the 2x, then f of x is, here we have a chain rule problem. We have cosine of stuff, so the derivative of cosine of stuff is negative sine of the stuff. And now we have to take the derivative of the stuff. So derivative of e to the stuff has stuff in it. So the derivative of e to the stuff is e to the stuff times the derivative of its stuff, which is 2. So now we end up f prime of x is equal to negative 2 e to the 2x sine of e to the 2x. That's kind of messy. Sorry. Negative 2 e to the 2x sine of e to the 2x, which is choice E. Number 6, an equation for the line tangent to the graph at y equals 3x minus cosine x at x equals 0 is. So we must take the derivative to find the slope of the tangent line, which is 3 plus sine x, because the derivative of cosine is negative sine. Since we already have a negative cosine, that's going to change the sign to a positive. And then, as we always do with the equation of the tangent line, we write out y minus y1 equals m times x minus x1. And we know x is 0, so this becomes a 0. So really we just get x, we get m times x, whatever m is. We can find the slope now. So dy dx at x equals 0 will give us the slope. That's 3 plus sine of 0. In a unit circle, if we're at 0 degrees, we think of the point 1 comma 0, and we take that coordinate's y value. Sorry, that point's y coordinate, and we would get 0. So the slope is 3. 3 plus 0 is 3. And we also have to get y1. So y is equal to 3x minus cosine x. We need to get the value when x is 0. So 3 times 0 is 0. Cosine of 0 is is the x-coordinate of that point on the unit circle, so that's a 1. And 0 minus 1 is negative 1. So now we have y minus 1 equals 3x. Making this look like what we have, we would add 1 on both sides. We would get y equals 3x plus 1. Choice C. Number 7, whoops. Number 7, if f of x is tan 3x and f prime of pi over 9 is the following. So f of x is tan of 3x. F prime of x, well, we have tan of stuff, so to take the derivative of tan of stuff is secant squared of the stuff times the derivative of the stuff, which is just 3. So f prime of x is really just 3 secant squared of 3x. So now we have to find f prime at pi over 9. So we're going to plug in pi over 9 into this function. And 3 times pi over 9 is pi over 3. In order to do this by hand, you would need to have a familiar angle. You'd need to have some multiple of 30, 60, 90, or 45. And we do. So pi over 3 is 60 degrees. So we want to draw a reference triangle, our 30, 60, 90. So across from 30 is the side of 1. Across from 60 is the square root of 3. Across from the hypotenuse is 2. So we now want to find the secant of pi over 3, which is, this is really 3 over cosine squared of pi over 3. And cosine, get this out of the way, cosine is adjacent over hypotenuse. So if we're at 60, our adjacent side is 1, and the hypotenuse is 2. So the cosine of pi over 3 is really 1 over 2. Well, we need to square that. So cosine squared is 1/2 squared, which is a quarter. So now we get 3 over a quarter, which when you divide by a fraction, you multiply by its reciprocal. So we're going to do 3 times 4 over 1, or 3 times 4. Final answer should be 12. Choice D. And yes, you do need to know trig. As some of you brought up, yes, you do have to have a knowledge of how to get that value. All right, number 8 says, the graph of a function is shown. Which of the following statements is about f is false? If you were to trace out the graph of this function, you would notice at A, you have to pick up your pen to graph it. So if you have to pick up your pen, that means the function's not continuous at A. We want which statement's false. So statement D is false. F is not continuous at A. Limit as x approaches A of f of x exists. If you think about the shutter method for a minute, what you don't want to do is you don't look at what's happening at A. What you do is you look at what's happening as you get closer and closer to A. So as you get closer and closer to A from both sides, the limits meet up. So that works. That's actually true. This is true, so we don't want it to work. The limit as x approaches A from the left has to agree with what's happening from the right. So that is true. F of A exists. F of A, you don't look at the sides. You look at exactly what's happening at A, and there's a filled-in circle, so F of A exists. That's true. And we haven't discussed relative minima. And x equals A, the function does not have a relative minimum because what happens here, well, you know what, we're going to discuss relative minimum later on. So this discussion might be a little premature, but you can still get the answer to the question without knowing what that choice means. All right, if A is not equal to 0, then this limit equals. So we have the limit as x approaches A, x cubed minus A cubed over A to the 6th minus x to the 6th. If you plug in A, you would get A cubed minus A cubed, which is 0 in the numerator, and you would get A to the 6th minus A to the 6th in the denominator, which is also 0. So we would get 0 over 0, which means time to do some algebra. So if we do some algebra on this, we have the limit as x approaches A. I'm going to leave the top alone because there's really nothing we can do on the top. You have the difference of 2 cubes up there. But the bottom is the difference of two perfect squares. So if you factor the bottom, you would get a cubed minus x cubed times a cubed plus x cubed, which is fantastic. This guy and this guy are opposites of each other. So they do cancel, but they cancel with the effect of that you have a -1. So we have the limit as x approaches a now of -1 over a cubed plus x cubed. Now if you plug in a for x, you would get -1 over a cubed plus a cubed, which is -1 over 2a cubed, which is choice C. Number 10, if f of x is x times the square root of 4x minus 1, then f prime of x is, if you read this, it's x times square root of 4x minus 1. So this is a product rule question. 4x minus 1 should be rewritten, square root of 4x minus 1 should be rewritten as 4x minus 1 to the 1/2. And taking derivatives, derivative of x is 1. Taking the derivative of 4x minus 1 to the 1/2, we would get 1/2. 4x minus 1 to the -1/2 times 4. So now we can figure out what this would be with the product rule. So crossing these up. By the way, the 4 divided by 2 becomes a 2. So keep that in mind as well. So we would get x, and we would really get 2x over square root of 4x minus 1 plus 1 times the square root of 4x minus 1, which I'll write like this. Now that's not a choice. So what we have to do is, it looks like they want us to get a common denominator. If you take a look, there's only one denominator in the answer. So we would multiply this last guy, which is really over 1 currently, by 4x minus square root of 4x minus 1 over square root of 4x minus 1, which consequently becomes, let's see, we get f prime of x to equal 2x plus, when you multiply a square root by itself, it removes the radical, over the square root of 4x minus 1. And 2x plus 4x is 6x minus 1 over radical 4x minus 1, which this turns out to be choice A. I like that one. It's a good problem. Number 11, if f of x is that function that f prime of -1 is, this is a standard power rule question. Can't get it wrong. You must rewrite 1 over x squared as x to the -2 before we take its derivative. F prime of x is -5x to the 4th plus 1 minus 2x to the -3rd. This is not good for evaluating the function, so I'm going to rewrite this. -5x to the 4th plus 1 minus 2 over x to the 3rd. And now we want to find what f prime of -1 is. Please be careful when you plug in. Always use parentheses and don't write the wrong power like I just did. Important. -1 to the 4th is 1 times -5 is -5. Another important thing, we have plus 1, and then -1 cubed is -1, but we're subtracting, so this becomes a positive 2. And now we get -5 plus 1 plus 2, which is, well, that's just -5 plus 3, which is -2. Final answer is -2, choice C. Number 12. They love double chain rules. So first things first, I want to write this as cosine of x squared raised to the 3rd. That's much better. So now we're gonna take the derivative stuff to the 3rd, which is 3 times stuff squared times derivative of stuff. So inside the stuff we have cosine of stuff. So the derivative of cosine of stuff is negative sine of stuff times the derivative of the stuff, which is x squared, which is 2x. So altogether here we have a -3 times 2, which is -6. We have the x lingering around. And we have, it looks like well, it doesn't really matter here, cosine squared of x squared times sine of x squared. Which this looks an awful lot like, which choice? Oops, it's -6x, sorry. -6x sine x squared cosine squared of x squared is the best choice, choice E. All right, number 13, an equation of the line tangent to the graph of y equals cos 3x at pi over 6 is the following. So we have y as cos of 3x. We have to take the derivative. Derivative cosine of stuff is negative sine of stuff times the derivative of 3x, which is 3. So we get the derivative to be negative 3 sine of 3x. Now we need to evaluate this derivative at pi over 6. Well, before we even do that, we want the equation of the tangent line. So y minus y1 is m times x minus x1. We have to fill in what we know. So we know pi over 6 is x. We have to find the y value. So the y value, or the y1 value, would be cosine, the original function, of 3 times pi over 6. 3 times pi over 6 is pi over 2. So that's 90 degrees. We're looking at the unit circle at 0, 1. The cosine value is the x value, which is 0. So cosine of pi over 2 is 0. So the y1 vanishes. So we get y equals whatever the slope is times x minus pi over 6. So now we can come back to the derivative to get the slope. So dy over dx at x equals pi over 6 would be negative 3 sine of 3 pi over 6, which we said before, 3 pi over 6 was pi over 2. And now we're looking at the sine value. The sine value is the y value, which is 1. It's the y value in the unit circle, which is 1. So now we end up with negative 3 sine, sorry, not sine. We just talked about that, the fact that that's 1 now, which is negative 3. So here's your slope. Negative 3 is the slope. And we end up with choice C being the answer. Pretty straight up. All right, number 14, we have an implicit diff question. So here we go. Taking the derivative with respect to x on both sides, we would get, what's the derivative of x cubed? Well, that's 3x squared, plus a little product rule here. So we get, we have 2x, we have 2x squared and y. So when we take the derivative of 2x squared, we get 4x. Derivative of y is dy over dx. And now we can cross them and get the product rule answer. So we get 2x squared dy over dx plus 4xy. Or I'll just write 4y because I want to get it wrong. Let's see, we have 4xy minus 4 dy over dx equals 0. I'll elect to bring over, well, it doesn't really matter because we're going to find out when x is 1 what the answer is. So I'll bring over the negative 3x squared rather and the 4xy. So we end up, let's see, with, 2x squared dy over dx minus 4 dy over dx equals negative 3x squared minus 4xy. Factoring out a dy over dx, we get 2x squared minus 4 equals negative 3x squared minus 4y over, dividing by 2x squared minus 4. So we get dy over dx is equal to negative 3x squared minus 4y over 2x squared minus 4. So there's what we have, and there's the derivative, and we want to find out what this is when x is 1. So when x is 1, so far we have negative 3 times 1 squared minus 4y over 2 times 1 squared, which is 2 minus 4. So we would get negative 3 minus 4y over negative 2. But we still need the y value. So what we need to do is go back to the original curve, which is x cubed plus 2x squared y minus 4y equals 7. Sorry, I forgot what that was. X cubed plus 2x squared y, and minus 4y is 7. And we need to find out when x is 1 what y is. So when x is 1, we get 1 cubed, which is 1, plus 2 times 1 times y, which is 2y, minus 4y equals 7. So we end up with 1 minus 2y is equal to 7. Subtract 1, and we end up with, negative 2y being 6, divided by negative 2, and y is negative 3. So if y is negative 3, now we can really evaluate this thing properly, and we would get negative 3 minus 4 times negative 3 over negative 2, which is negative 3 plus 12, because we're subtracting a negative, over 2, which is 9 over 2, which is hopefully a choice. And 9 over 2, oops, went wrong somewhere. Let's see. Sorry, this should have been a negative 2. I see where I went wrong. This should have been a negative 2. This should have been negative 2. So 9 divided by negative 2 is negative 9 over 2. And now we have the choice A. 15. The graph of the function is shown. Which of the following statements about f is true? The limit as x approaches a of f of x, which if you use the Shutter method, this is a 4, is equal to the limit as x approaches b. Well, the limit as x approaches b doesn't exist because the left and the right-hand sides don't agree, so that's not right. The limit as x approaches a is 4. Well, we just said that. That's true. So we're done. And I'm not even going to go on for the rest of them. Number 16, evaluate the limit as x approaches 1 of ln of x over 3x. Limit as x approaches 1 of ln of x over 3x. The first strategy is you're going to plug in the 1 and see what happens. Well, ln of 1 is 0. That's because e to the 0 is 1. Divided by 3 times 1 is 3. Well, 0 divided by 3 is 0. So guess what? We're done. That was the easiest problem I think we've ever seen on here. All right, number 17. Let f of x be the limit as h goes to 0 of x plus h squared minus x squared rather over h. For what value of x does f of x equal 4? We have the limit as h goes to 0 of this thing. This is a derivative. So first thing you need to realize what function it is, and it's x squared. This tells you, or even this tells you in this format, f prime of x is 2x. So really now they're asking, for what value does f of x equal 4? So they're really asking, when does 2x equal 4? Well, divide by 2, and x is 2. So very easy question if you recognize that the limit as h goes to 0 is a derivative. All right, number 18, if f of x is equal to e to the 3x over 3x, and f prime of x is, well, this is a quotient rule problem, so we need to identify the high function, the low function, the derivative, and their derivatives. So the high function is e to the 3x, the low function is 3x. The derivative of e to the 3x is it's e to the stuff, so it repeats itself times the derivative of the stuff, otherwise known as 3e to the 3x, and the derivative of the low is 3. So now we get low d high. So low d high is 3x times 3e to the 3x, which is 9x e to the 3x minus, so we did low d high minus high d low, so we have 3e to the 3x divided by low squared, which is 3x in parentheses squared. So we end up with f prime of x being 9x e to the 3x minus 3e to the 3x over 9x squared when you simplify the 3x in parentheses squared. So that's not a choice, but if you notice, all the coefficients can be divided by 3. As long as they all can be divided by 3, this is okay. So we get a 3, a 1, and a 3. So the derivative is 3x e to the 3x minus e to the 3x over 3x squared, which we don't see. But if we factor out an e to the x on the top, we'll be, an e to the 3x on the top, we'll be able to see this. So we get e to the 3x parentheses, sorry, I just lost my train of thought, 3x minus 1 over 3x squared, which is choice E. Number 19, let f and g be differentiable functions with the following properties. We know f of x is less than 0 for every x, and g of 5 is 2. So they told us that h of x is f over g, and h prime happens to be f prime over g. But we also know another way to get h prime. Well, it's the quotient rule. So the high function is f, the low function is g, high prime is f prime, low prime is g prime. So let's do this. Low d high would be g of x times f prime of x minus high d low, which would be f of x times g prime of x over low squared, which is g of x squared. Okay? All right, this question's a little tougher than I thought it was when I first looked at it. So here's how to do it. I wouldn't hold you responsible for this on the test, but what you want to do here is we need to figure out a way to get this somehow. And what you can do is separate this into two fractions. And if you do that, we would get g of x f prime of x over g of x squared minus f of x g prime of x over g of x squared. So what happens is this first fraction, one of the g of x's goes away. And so you get f prime. So h prime of x right now, if you follow this through, h prime of x equals f prime of x over g of x minus this other term. But we also know that h prime of x is just equal to f prime over g, which is this term. So what that means is since h prime of x is equal to this, from the quotient rule, we got h prime of x is equal to this term minus something else. The something else part has to be 0 because we know that h prime of x is just equal to this first term. So the second term has to equal 0. So that's conclusion number 1 here. This second term has to be equal to 0. Secondly, if a fraction is equal to 0, its numerator is equal to 0. So it's really, I don't care about the denominator. If you want to multiply through by it, that's fine. So we get f of x g prime of x is equal to 0. Now they gave us some other clues. They told us that f of x was always less than 0. So if you think about what we have now, we have something times something equals 0. That means one of the pieces has to be 0. But they told us, we were told, that f of x is always less than 0. So this is always a negative quantity. It's never 0. So that leaves g prime of x to be equal to 0. So if you think about g prime of x being equal to 0, where did that come from? Well, we know the derivative is 0, so let's think about that for a minute. That means the original graph had to have a slope of 0 all the time. Well, what kind of graph has a slope of 0? Well, a line, a horizontal line, has a graph of slope of 0. Okay? So any of the horizontal lines could have been g. Okay? But then they told us something. They also told us that g of 5 was 2. So wherever 5 is, the x value, the y value had to be a 2. So now we know not only that this is a horizontal line, we also know the height at which it's at. It has to be a 2. So g of x, the original function, had to be equal to 2 because that's the only function that's going to produce 2 when x equals 5 is input into it, and also produce a derivative of 0. So g prime of x is identically equal to 2, which is choice E. That will not be on your test. That's a tough one. I may do something like that as a bonus, but that's a hard question. All right, number 20 says, what is the instantaneous rate of change at x equals 3 of that function? So this function is a quotient, so instantaneous rate of change is another word for the derivative. I hope you realize that by now. So we're going to use the quotient rule. My high function is x squared minus 2. The low function is x plus 1. High prime is 2x, and low prime is 1. So now we have low d high, which is x minus 1. X plus 1 times 2x, which I'll write like this, minus low d high minus high d low. So I even sing the song when I do it. X squared minus 2 times 1. I'll leave the 1 out. Over the low square, which is x plus 1 squared. Now you can go simplifying this, but I just need to plug in 3 and get a number. So 2 times 3 times 3 plus 1 is 4, minus parentheses 3 squared is 9 minus 2, over 3 plus 1, 4 squared is 16. 2 times 3 is 6 times 4 is 24, minus 7 over 16, which is 17 over 16, choice E, and we're good to go. All right, 21. Where the limit is at h approaches 0 of 25, square root of 25 plus h minus 5 over h. This is a derivative question. We have to realize the function we're taking the derivative of is square root of x. Just replace the 25 plus h with an x. So, by the way, this is x to the 1/2. If you rewrite it, taking its derivative, we have 1/2 x to the negative 1/2, which is known as 1 over 2 root x. So now we have f prime at 25. Careful, the number we're plugging in into the function is 25. So we've got to remember, this comes from the square root of x. This comes from the square root of 25, which is 5, but the x value is actually 25. So we have f prime at 25, which is 1 over 2 radical 25, which is 1 over 2 times 5, which is 1 over 10. Choice B. All right, 22, consider the curve x squared plus 3y squared equals 1 plus 3xy. We want to show that dy dx is equal to that. So by implicit differentiation, which I hope we're really getting very good at. So we have derivative of x squared is 2x, derivative of 3y squared is 6y dy over dx equals derivative of 1 is 0. And here we have a little mini product rule question. We took the derivatives, and now we're going to cross them, so we get 3x dy over dx plus 3y. Moving terms over, I'll just subtract the 3x dy over dx and subtract the 2x. You could have done it the other way around. You would end up getting 6y minus 3x after factoring out a dy over dx, and that equals 3y minus 2x. Divide by 6y minus 3x. And we get dy over dx equals 3y minus 2x over 6y minus 3x. I have to caution you, if you got this answer because you moved the terms the opposite direction that I did, you would have gotten this answer, which is identical to the answer that I got. Okay, so be on the lookout. And this is the answer that they want, so you'd have to switch this to this and box it in. All right, it says find all points on the curve whose x-coordinate is 1, and write the equation for the tangent line at each of these points. So if we're looking at the original curve to find these coordinates, the original curve is x squared plus 3y squared equals 1 plus 3xy. So the original curve when x is 1, we get 1 plus 3y squared equals 1 plus 3y. This is a quadratic. We're going to move everything over to where the quadratic term is. So we get 3y squared minus 3y. The 1's go away, which is nice, equals 0. So the 3y factors out. And we get 3y times y minus 1 equals 0. So there's two y values here. Be careful. Y equals 0. A lot of kids forget that y value. And y equals 1. So now we have all the points of the curve whose x-coordinate is 1. We have the point 1, 0, and we have the point 1, 1. So now we have to figure out the tangent line equations, which is pretty easy. Y minus y1, which is 0. So actually we can just write y equals the slope times x minus 1. So now we have to get the slope. I'm going to just come up here and talk through the slope. 3 times 0, because 0 is y, is 0, minus 2 times 1 is negative 2. So our slope is negative 2 over 6 times 0 is 0. Minus 3 times 1 is negative 3. So our slope is 2/3. 2/3, done. There's 1. Now we have to do 1, 1. So 3 times 1 is 3. 2 times 1 is 2. 3 minus 2 is 1. So actually, I should fill this in first. And now we get our slope. 3 minus 2 is 1. Over 6 minus 3, because the y's and the x's are just 1, 6 minus 3 is 3. And so we get 1/3. So there are your tangent lines. And now part C says, find the coordinates of each point on the curve where the tangent is vertical. So finding points on the curve where the tangent is vertical requires us to set the denominator equal to 0. So we have the denominator of the derivative equal to 0. So we got 6y minus 3x is equal to 0, which is equivalent to saying 6y equals 3x, which is equivalent to saying, I'm going to do this backwards. I'm going to solve for x just because it's a little neater. X is equal to 2y. So if x is equal to 2y, if we go back to the original curve, whenever we see an x, we can substitute a 2y in for it. So we have 2y squared plus, in parentheses rather, 2y squared plus 3y squared is 1 plus 3 times 2y times y. So 2y parentheses squared is 4y squared plus 3y squared is 7y squared. That equals 3 times 2 is 6y squared plus 1. So now this becomes a really nice equation. Minus 6y squared on both sides. We get y squared is positive 1. Taking a square root, y is plus or minus 1. And so that's our y coordinate. There's two of them. So we have, if you think about the answers, we're going to have something comma 1, something comma negative 1. So if y is positive 1, 2 times positive 1 gives us positive 2, which is the x. And if y was negative 1, it would give us negative 2. So here are your answers.